Earth is home to some pretty big things, like this piece of paper. Wait. Earth is home to some pretty big things, like this backpack. But how do we get these big things? Well, it's not hard to believe that Earth and everything on it has come from something even bigger, the Big Bang. The Big Bang was basically an explosion creating everything that we know today. But how do we know it actually happened? Today we're going over 3 big pieces of evidence for the Big Bang. During the 1600s, our universe was seen as infinitely large with an infinite number of stars. This wasn't until Olber's paradox came along, which basically said that if the universe is actually infinite with an infinite number of stars, every time we would look into the sky, we would look at the surface of a star. Despite the fact that we don't really know if the universe is infinite, we know that there hasn't been enough time since the beginning of the universe for the light of distant stars to travel to Earth. When the universe began 13.8 billion years ago, that is still not enough time for the light from distant stars to reach Earth. The fact that the universe must have had a start provides evidence for the Big Bang. Edwin Hubble was a pretty smart guy. Using the distance stars are away from Earth and the Doppler effect to figure out how fast they're moving, was able to create his own constant called Hubble's constant. Hubble's constant is basically a constant velocity, which explains how fast objects in the universe are moving away from each other. So not only do we know that the universe is expanding, but it also provides evidence for the Big Bang. I want you to imagine 2 people standing back to back. Both of them take 5 steps forward at a constant velocity. When we turn back the clock at time 0, they're both standing back to back. This is the same idea with our galaxies. If they have a constant velocity moving away from each other, if we turn back the clock, they must have been together at some point. Which is exactly what the Big Bang says. A black body is a hypothetical object that is used to measure how much energy an object is radiating. Usually, everything follows a black body spectrum, and at certain temperatures, any object releases certain wavelengths of energy more so than others. It wasn't until 1964 this actually had relevance to the Big Bang, when the cosmic microwave background was discovered. This is basically just uniform and constant radiation of microwaves that engulfs our universe. So you might be thinking, was there a certain large energy source that dissipated 13.8 billion years ago that created the cosmic microwave background that we know today? Actually, yeah. If we were to actually plot the wavelengths and the temperature of the cosmic microwave background, we actually get a black body spectrum. That means the light and heat from the Big Bang that happened 13.8 billion years ago had dissipated until the present day, now received as microwaves.